Well, here, and this is basically the final new topic. It's called equations that are quadratic in form. Um, what does that mean? Well, they don't look quite right, but they actually can be worked with. So in this example here, we have x to the fourth power minus 5x squared plus 4 equals 0. The crucial thing is, and what I do is focus on the middle expression, and ask: is it the case that if you square this middle, the x squared, do you get x to the fourth power? You do. In other words, there's something about this first term being the square of the second term in terms of x, not in terms of the coefficients, but in terms of the x or the variable expression. If that is the case, then we have the kind of problem we can deal with. And the best thing, and I agree with this, is to use a substitution, a form of substitution. And typically, the this is just really for convenience. We use the letter U for that instead of other letters. There's nothing really sacred about that, but the letter U seems to do the job. So what I do is I say let U be equal to the variable part of the middle term of the middle term, and then as a check, make sure that if you were to square both sides, U squared, you would indeed get what's showing up on the in the first term. If you don't, then something's off, and we need to recheck things. That's for sure. But with that in mind, we're now not going to use x, we're going to use the letter u and go through exactly the same kind of algebra we've been doing with the quadratic formula or whatever method. I use the quadratic formula here, but you can use completing the square. Anytime you do the quadratic formula, you can use completing the square and vice versa. If you're wondering, well, why do we have two methods? The answer to that is we need these separate methods for other reasons later on. That's what it's basically going to come down to. But in this case, I don't know if I could have used factoring or not. The AC method, see -4. I believe I could have. I just didn't here. So no big thing. Whatever method you use, here I use the quadratic formula, and nothing new in terms of procedure. But what is new, and you must not forget, and it's common to forget this, when you get some numbers, some nice simple numbers in this case, 4 and 1, you're not done yet. You're definitely not done yet because you're not trying to solve for u, you're trying to solve for x. The u is like a middleman or a temporary variable or something of this nature. So that's why I have in green here, bring back the x. So in other words, ask yourself, what was u supposed to be equal to in terms of x? Oh, x squared. Right, we're really saying x squared equals 4 and x squared equals 1. So this is where I split this off into two separate equations, solving x squared equals 4 and x squared equals 1. Take the square root of both sides. We're following that principle of the square roots from earlier videos. And observe we're getting two answers for each one of these equations, just like we would expect. And so ultimately we have four solutions here. It turns out four distinct solutions. And just as a little background, this is not a mystery, or I'm saying it's a mystery, it's not a surprise. We have four answers, and the polynomial we started with is fourth power as its highest power, and that's called the degree of this polynomial. It's a fourth degree polynomial, fourth degree. And with that, we get four solutions to this kind of problem here. Sometimes the solutions may be repeated in a way, so but you won't have more than four distinct answers. That's for darn sure. So I hope that's enough for this situation. The situation here was we have exponents which are, well, multiples of 2. I guess that's a fair way to put it. Well, the other example, or at least a second example I have here, is what if the exponents are themselves fractions? So here we are in this second example, x to the 2/3 power minus 5 times x to the 1/3 power plus 4 equals 0. So on red here, I'm checking if I square the x to the 1/3 power using the rules of exponents, do I get back what should be in the first position here, the first term, and it does. in a sense, the x to the 2/3 power is the square of x to the 1/3 power. It literally is. It literally is. Okay, so we're ready to go. Just as before, you let u equal the middle kind of variable expression, and I always add the note that make sure that if I square both sides of my assignment here, I get back basically the first term, and I do. Now, with that, we have the quadratic u squared minus 5u plus 4, which is exactly the same quadratic we had in the first example. So I don't rewrite all that. You just go back to that first example we've just done, and I'll when I get done with these, I'll bring back that first example so you can give you time if you didn't write it down. Forgive me for that. But the idea is, well, we still have the basic solution, u equals 4 and 1, but now this is where things can differ. Remember what u is in this example is x to the 1/3 power. It's the cube root of x, cube of the x to 1/3 power. So it's x to the 1/3 power is 4 or 1. Cubing both sides, that's a way of solving a cube root problem, or if you like, a x to the 1/3 power problem. And therefore we have x equals 64 or 1. And I'll just take a minute here so you can jot this down. I will come back to the first one at the end, so you can have another shot at that for writing this down. Okay, I hope that would be sufficient, and just in case, just making sure that the focus and all that's good, and sometimes readjusting the position is helpful. Okay, so one more example of this kind of situation is this here. All right. So what's going on here is we have x minus 5 times square root of x plus 4 equals 0. Now, the crucial thing to consider is whether this x is the square of the square root of x, and indeed it is the case, which I've written out in red here. So everything is tidy and acting like it should. And really, you just stick to your guns here. You let u be the middle variable expression. In this case, u equals square root of x. Just making sure everything is tidy. U squared is equal to x, given that u is equal to square root of x. Very good. Here I wrote out the quadratic in its kind of pure form. Notice it's the same quadratic as the other two examples, so I get to save on work here. And then we come to the end of this stage. We have u equals 4 and 1 again. But now we have to be careful that we're saying the square root of x, because that's what u is equal to here, is equal to 4 or 1. Split off into two separate equations, solve for x. Here we're going to be squaring both sides because our x is trapped inside a square root, and therefore we have x equals 16 and 1 as our solutions. So again, let me just leave that there for a second. You can pause the video to jot this down, this problem down. Okay, and I promised to bring back the first one, the one that had all this detail, and I just kind of railroaded on through it. So this was the first example here. And I don't know if there's much I could do with that. I could make that maybe like that. Ooh. That's probably too extreme. Not much I can do that. Well, let me make that, try to bring that, just make sure, I hope this is readable. But you can stop the video and write that down, and let me bring this up here. So the bottom part, yeah, this problem had a lot of computation work. So, okay, I take it that that's been enough opportunity for you to pause the video to jot this down. I hope these have been a sufficient number of examples. Please let me know if it is or is not. Right, and I think that completes really most of the material for 3.2. There'll be an additional extra credit sort of, I don't know, topic, relationship between the quadratic formula and the quadratic equation. I'll do that in another video there to try to illustrate what the extra credit will consist of. So thanks a lot.